Okay, algebra students, we are going to start our first flipped lesson. This is 2-1, graphing and writing inequalities. Our objectives are to identify solutions of inequalities with one variable, write and graph inequalities with one variable. Okay, an inequality is a statement that two quantities are not equal. The quantities are compared by using the following signs. Okay, so if you have A less than B, this is your less than symbol. If you have A is greater than B, this is your greater than symbol. You can have A is less than or equal to B. Or you could have A is greater than or equal to B. Okay, and then let's see, there's 4, you have one more. This means not equal to. Alright, so when we're graphing a less than symbol, you're going to have an open circle because it's not part of your solution. The same with the greater than symbol. When you're graphing with the less than or equal, you're going to have a closed circle. With greater than or equal, you're going to have a closed circle, and I'll explain that more here in a minute. And then when you have not equal to, you're not going to include that solution, so it's going to be open. Okay. A solution of an inequality is any value of the variable that makes the inequality true. Describe the solution of x minus 6 is greater than or equal to 4. Okay, so we have x minus 6 greater than or equal to 4. In class, you treat this like you do an equation. We want to isolate our variable x, so the inverse of subtraction is addition. Make sure you do it on both sides of that inequality. The negative 6 and the positive 6 cancel out, so on the left side I have x. Bring down my inequality symbol. On the right side I have 10. So it described the solution in words, so the solution is all real numbers greater than or equal to 10. So that's how you would describe it in words. Okay, so let's test one. What is a number that is greater than or equal to 10? Well, let's use 11. Okay, so 11 minus 6 greater than or equal to 4. Substitute 11 in for your variable x. 11 minus 6 is 5. Is that a true statement? Yes. So 11 is one of your solutions. Okay, let's try 10 because it says equal to 10. Substitute 10 in for x. 10 minus 4 is 4. Is 4 greater than or equal to 4? Yes, so that's part of the solution. Okay, let's pick a number that is not greater than 10. Let's pick 9. Okay, 9 minus 6 is 3. Is 3 greater than or equal to 4? No, it is not. Therefore, 9 is not part of your solution set. That's why the solution is all real numbers greater than or equal to 10. Okay, we're going to do the same thing here. You want to isolate your variable p, so the inverse of multiplication is division. Your 2's cancel out, so I have p is greater than 4. Okay, so describe. Solution is all real numbers greater than 4. inequality like 3 plus x less than 9 has too many solutions to list. You can use a graph on a number line to show all the solutions. Okay? So if we were to solve this, we would isolate that variable x. Inverse of a positive 3 is a negative 3. So when you graph this, your solution set is all real numbers that are less than 6. But are we including 6? We're not. It says less than. So that's why you have this open circle. If we would have had less than or equal, then your circle would have been closed. But because we don't in the inequality, it is open. Okay, the solutions are shaded and an arrow shows the solution continued past those shown on the graph. To show that an endpoint is a solution, draw a solid circle at the number. To show an endpoint is not a solution, draw an empty circle. So 6 is not part of that solution, so it's not going to be part of the solution. Guys, if you do it on the number line, sometimes you'll see me put an open circle and go this way. Okay? All right, graphing inequalities. All real numbers less than 5. Open circle. All real numbers less than 5. All real numbers greater than negative 1. Open circle. Greater than negative 1. All real numbers less than or equal to 1/2. So 1/2, it is part of our solution. So this is a closed circle. Your solution set goes to the left because it's less than. All real numbers greater than or equal to 0, we are going to include 0, and all the numbers greater go to the right. So there's your graphing inequalities. Okay, so right now we are going to graph each inequality. Okay, so for A, I have 3/4. This says M is greater than or equal to 3/4, so 3/4 is going to be part of my solution, and it's all real numbers greater. So that's how you would graph A. Okay, on B, we need to simplify the right side of this inequality. So -1 plus a positive 3 is 2. 2 times 5 is 10. So T is less than 10. So 10 is not part of my solution, so it's an open circle, and the solution set is all real numbers to the left of 10. And then on C, we need to simplify the left side. 2 squared is 4. 4 minus 4 is 0. Okay? Now, this one's a little tricky. Okay. This is saying that 0 is greater than or equal to W. W is where our solution set. 0 is greater than or equal, so I know it's a closed circle. 0 is the greatest number, so your solution set goes to the left. Okay? If you wanted to rewrite it where your variable is on the left side, you would need to flip that inequality symbol. W is greater than or equal to 0. Back up, guys. I didn't flip it. That's not right. It would be less than. I need to flip that inequality symbol because your solution set is going to the left. Okay, now what we're going to do is we're going to write some inequalities. We're going to look at the graph and write an inequality, okay? You can use any variable you want. I'm going to use x, and then my solution number is 2.
David Horton, if you are in the building, please come to the office. David Horton, come to the office, please.
All right, we are not going to include the 2, so it has to be less than or greater than. Our solution set is going to the left, so it's less than. And then for this one, I'm going to use my variable x and -5/10. Okay, We are going to include the negative 5/10, so I'm going to have that equal sign. My solution set is real numbers to the right, which are greater. So x is going to be greater than or equal to negative 5/10. Okay. Reading math. No more than means less than or equal to. So if I have no more than $10, how would you write that, guys? Well, here's my x, here's my 10. Can I have more than 10 if it says no more than? I cannot. 10 is the greatest. Can it be equal to 10? Yes. So that's why no more than means less than or equal to with the inequality symbol. At least means greater than or equal to, okay? Let's say I have at least $20. Okay, can it be equal to 20? Yes. When I say at least, is what my solution set, is it going to be more or less than 20? It's going to be more. So when you see at least, you use your greater than or equal to, inequality symbol. Okay, so we've got a word problem here. Ray's dad told him not to turn on the air conditioner unless the temperature is at least 85 degrees Fahrenheit. Okay, so at least 85 degrees Fahrenheit. Define a variable. Write an inequality for the temperature at which Ray can turn on the air conditioner, and then graph the solutions. We got a lot going on here. Okay, so first it says define a variable. So let's let T equal the temperature, because that's what we're trying to find here, okay? All right, then it says write an inequality. So we have the temperature has to be at least 85 degrees. So can we include 85 degrees? Yes, so there's your equal sign. When it says at least, is it going to be more or less than? The temperature needs to be higher than 85 degrees. So there's our inequality. All right, so define the variable, write an inequality. Now it wants us to graph it. We're going to include the 85, so it's a closed circle. Solution set is all the temperature that is higher than 85 degrees. All right, now I can do an exit slip. So that is it for tonight's lesson. I will see you all in class tomorrow. Have a good one.